Hello everybody and welcome to the next session of our Digital V-Days. My name is Markus Eberle and I will moderate this session today, and I'm very happy to welcome also my colleagues Jens and Balázs, so Jens Ruckes and Balázs Markus, who are working as in the software development team in the field of wireless connectivity and sensors at Würth Elektronik. They will hold today's presentation and also answer your questions at the end of the presentation. Yeah, the topic of today is enough with the theory, what it really takes to get sensor data into a cloud. So the presentation will be about 35 minutes long, and then after that we have scheduled a Q&A session. So yeah, we will then answer all your questions. If we can't answer all your questions there, we will answer it later on. And if you have any questions left after the webinar, just email us. And if you have a technical question, directly go to wc@we-online.com. There you will be directly at the technical support for the field of wireless connectivity and sensors. So you will also receive the link to the presentation as well as to the recording from us by email. And yeah, with that said, I'm happy to give it over to Jens and Balázs, and I wish you an exciting webinar.
Yeah, let's head right into the agenda. I mean, this is for your completeness, so
exactly.
We'll go right on to the first slide. Yeah,
perfect. So exactly, today we are going to jump into the topic of IoT and cloud connectivity. In the first part, as you could saw it in the agenda, we are going to jump into general topics about IoT and cloud definitions, just giving a little introduction to the topic. And in the second part, we are going to discuss security features, how could you make your IoT application a little more secure. So let's first clear some things up. IoT, it's the abbreviation of Internet of Things, which basically an entire network of physical devices, tools, appliances, equipment, machinery, and other smart objects that have capability to collect data about the physical world and transmit the data through a network. Now, what is cloud, you might ask? Well, it's kind of a metaphor for a global network of remote servers that operate as a single ecosystem. It is commonly associated with the internet, but we have to know that it's not necessarily only the internet. These remote servers are designed to either store and manage data or run even applications to deliver content or a service, streaming videos, webmail, social media stuff, everything that you can imagine. And basically you can access this data from anywhere with any kind of internet connected device or any kind of device that's connected to the network. Quickly, I wanted to clear some definitions up. What kind of cloud deployments exist? There is a private cloud where the private cloud infrastructure has been deployed and it's maintained and operated for a specific organization, like for example, a company. And then there is the community cloud where more companies are coming together and they are operating such a cloud together. There is a public cloud. It's one of the most common examples. Here, the cloud infrastructure is available to the public on a commercial basis by a cloud service provider. We are going to look at some examples in this presentation. And there is a hybrid cloud, which is basically a combination of the previous ones, where we combine different types of clouds, and these clouds have the ability to communicate with each other. Most commonly, these clouds have a shared infrastructure, which means that they use a virtualized software model, and even the physical parameters and the memory, for example, for the hardware, it can be customized by our web interface by the user or the customer. And three things can be mentioned to this topic: as software as a service, where the service that the cloud provides is only the software itself, and the hardware parameters cannot be customized. Then there is platform as a service, where the customer can also purchase access to a platform and enabling to them to deploy their own software and applications as well. And of course, there is infrastructure as a service, which we already mentioned, where we can customize the hardware properties as well. Exactly. So let's just jump into the topic. Why is it beneficial for you to publish data to the cloud?
Yeah. I mean, it's pretty much in everyone's mouth and ear to use cloud for whatever at the end, because the possibilities are so vast that you can ask yourself, why do I want to have data in the cloud? Sure. And in principle, the cloud offers such a grade of scalability and accessibility that you can do tasks like process automation, optimization, real-time analysis, which is partnering up with IoT as itself to gain all the benefits that are hoped and sometimes even needed for applications. So this allows us or the application owner to handle a huge amount of data, which are generated by IoT devices like sensors or control actors in the products or in processes. So stuff like predictive maintenance, for sure, safety and security, quality control. I mean, it's listed all up here. So these are items that can be easily added, maintained, modified, and extended when you are with your data or with your applications data in the cloud.
Exactly. I think a nice summary of these terms that you just mentioned is that the companies or users who are using the cloud are able to deliver more value. They are enabled to react faster, act faster, and make decisions faster, which results in more productivity, I guess.
Yeah, exactly. Yeah. So next step would be, let's look at a potential IoT system and its key components.
All right. So at a basic level, IoT refers to any system of interconnected devices that have sensors and embedded processing abilities. Note that, as I already mentioned, these devices don't necessarily have to use the internet. Even locally connected devices interacting and exchanging data are an IoT system. With that in mind, we can break down the IoT infrastructure required to make an IoT system into the following elements that you can see on the screen. So first, we have some sensors, which are the eyes and the ears of IoT. They collect data from the environment. There is the host, which is usually a microcontroller. You can imagine any kind of microcontroller, even a development board, both from Würth Elektronik. And there is the wireless connectivity, which acts as a bridge between the cloud and the host. Very good examples for that are wireless modules from Würth Elektronik and the cloud itself. We already mentioned different types of clouds. We are also going to show you some examples in this presentation. Exactly. So this cloud is basically the place where all the data processing and the data ingestion and also the data visualization happens. So in the following slides, we are going to mention some technologies, because we mentioned it's not just simply internet. There are a wide range of wireless technologies that can be used for IoT applications.
Yeah. Thanks, Balázs. Yeah. So this is a rough overview of what could be acting as such a wireless technology to transmit data from A to B. For sure, it doesn't need to be wireless. It could be cable bound as well.
Exactly. Good point.
I mean, it's about the application at the end, because the options again are so, there's such a vast amount of options which the advantages and disadvantages that it's not easy to choose the right one. Sure. So that is one task for all application developers, to choose an optimal protocol and physical layer and all the packages that come together in here to form the communication backend of the IoT application at the end. So we have standardized stuff like Wi-Fi, LTE, 5G, and also we have proprietary protocols. For example, our own WProWare or LoRaWAN, which is coming from one company, so it's not standard. At the end, the target is to get data from A to B, and that's the important thing, ideally in a safe and secure way.
Exactly. We are going to talk about it later. So now onto the platforms where all this data is stored and processed. We said that we're going to mention some examples. There are leading cloud platforms like AWS, Azure, and Watson IoT. These platforms offer myriad of services designed for handling IoT data. They provide secure and scalable solutions, enabling seamless integration with various IoT devices and applications. We mentioned 3 examples here that there are a lot of IoT buzzwords. There are even new platforms coming up. Some of these platforms are optimized for industrial use. Some of them are optimized for day-to-day hobby projects. Most prominent ones are Amazon AWS, Microsoft Azure IoT, and IBM Watson IoT platform. You will find these platforms in basically all kinds of general applications. All right, and in most of them, they have a very flexible pricing scheme. So even as a small project owner, you can just join with your projects, and later on, as your project scales up, then you can still use these systems. And they are, as I already mentioned, you can even scale up the hardware, you can scale up the software, you can deploy basically everything on one place. So how do we implement IoT data into the cloud? Let's consider just a simple example. Here we are mentioning 4 steps to you. First, obviously, you have to connect your IoT device to the cloud, meaning you have to set up some kind of a connection using the either MQTT or HTTP protocols. And the larger work comes on the cloud side, where you have to actually set up the data ingestion. Probably you will set up some MQTT broker with some endpoints where we are going to publish some data, and this data has to be provided in a specific format. Probably JSON is a very common format. And then you have to configure. Maybe you want to write a Python script that parses the JSON that you just published via your microcontroller. And you also have to take care about processing and storing it. You can set up some simple database system, for example, InfluxDB running on an AWS instance, where you can insert your incoming data points and later you can process them with some real-time data processing framework. And after that, obviously, most of these platforms also provide an analytics and visualization tool where you can utilize the cloud platform tools for data analysis. That means you can create nice graphs or just create logs, whatever your taste wants. All right, but obviously not everything is that easy. There are always some challenges regarding IoT development. Jens can tell you something more about that.
Right, yeah. Because as an application designer or project owner, you will definitely face challenges already in prototyping, in pre-design phase, and during the design, and even after release of the process. So let's take a quick glance at some most common of them and what they are about. So interoperability, I mean, as the word said, it's about ensuring seamless communication and interaction between different devices of different manufacturers across different platforms using different protocols. So all variants in different, but one target. They should communicate and operate with each other, and that ideally seamlessly without any big interaction by the user. Scalability is something Balázs already mentioned. So if you scale up from prototyping phase with a couple of 100 nodes to tens of thousands of nodes, it's quite a challenge to do that without doing the same operation over and over for each module. So it's good to have some sort of automated process there that can apply like a set of settings to all devices that are member of your network, of your IoT network. Then next item is reliability and quality of service. So this is all about making sure that the data arrives at the data lake in the cloud, which for sure, if you know, your Wi-Fi sometimes breaks up. So you need to want to implement some security measures and retransmitting options so the data arrives in the cloud. Even with delay, it's often fine to have data with delay than not have data at all.
Exactly.
Next item we also spoke shortly about, it's about data management and analytics. So everything you can do with highly complex algorithms, as highly complex as you want, because you simply can book and scale up the hardware and apply all the methods that are needed. Well, the most or let's say the other way around, the most complex can be security and privacy. So it's our last but not least. It's quite important. Exactly. I mean, I do not want the data to be anywhere else than I choose to be. So that's about ensuring the security of the IoT devices on one end, so client side, and for sure also on the cloud side and on the transmission channel side. You want to prevent like man-in-the-middle attacks and prevent unauthorized access to data. And that's all about security and privacy. Yeah. So this would lead to our part 2.
Exactly. This directly leads to part 2 of our presentation, which is IoT security. So today I want to shed a light on the topic that's become increasingly permanent, which is the security of our so-called smart devices. Often the convenience of these gadgets overshadows their vulnerabilities. We are talking about those devices, lights, thermostats, cameras, any kind of smart IoT devices that have been commonplace in our homes. And they are marketed as smart, but are they really that intelligent? You might ask the questions, because, you know, IoT nowadays transform everything into a computer, and that creates a vast attack surface. And small IoT devices, they are usually very easy targets for hackers because they are connected to the network, but usually they lack all of those software and hardware security that are implemented in, for example, computers or any kind of large-scale user devices. But as these devices are becoming more and more complex, usually these hardware and software protections are not scaled up enough in terms of security. Just mentioning some IoT risks, privacy invasion, safety concerns, and as you mentioned, potential of denial of service attacks. We are mentioning 2 past incidents here that were pretty famous. They were also in the news. One of it is the Mirai botnet, which happened in 2016. It exploited weak security in IoT cameras and routers, and it caused massive internet outages. And there is also the WannaCry ransomware attack, which happened in 2017. It targeted healthcare systems, and it absolutely highlighted the critical need for robust security in IoT. All right, moving on to reasons for vulnerabilities. Why are these devices such attractive targets for attackers? So their simplicity is a double-edged sword. While it's appealing to us as customers and consumers, it's equally appealing to those with malicious intent. So like hackers, unlike computers and smartphones, as I mentioned, these devices often lack the latest hardware and a robust security feature. Exactly. So what makes it worse? There's no universal standard for designing and building these IoT standards. They operate on various protocols, Wi-Fi, Z-Wave, Zigbee, Bluetooth, which means there isn't a consistent set of security practices yet. This diversity of protocols makes it challenging to ensure standardized level of security across all of these devices. Why I mentioned yet? Jens is going to tell you more about this.
Exactly. Yeah, because there is, I mean, it's slow movement, but there is movement on the legal side, speaking for the European Union. So a couple years ago, actually, so 2022, the EU Cyber Resilience Act was introduced, implemented, and needs to be applied within a certain time range on certain regions of applications, which one of them is IoT, simply because A, it has radio equipment in it, then RED would apply, or it's like a medical application where a different set of rules are to be applied in order to reach the CE certification needed for selling a product within the EU. Yeah. So speaking of the radio equipment directive, we currently have a due date in August 2025 to apply a set of rules that are currently being discussed and developed by the CENELEC, which is the European Committee for Electronic Standardization. They shall put together a set of best practices, a set of rules, a set of tests that need to be applied by anyone that wants to sell an application on the EU market. So it's mandatory at the end. Yeah. So I will get into the details of the norms mentioned here, because these norms are existing today. It's highly reasonable to believe that as they are already existing, they will inherit some of their tests and items they point out towards the new standard that's coming up. But at the end, as of today, we don't know yet what we need to do in 2 years.
Exactly.
Yeah, so that's a bit of a bummer. Exactly.
Like
yeah. Good. I mean, what we can say already about the three known topics, or from the known norms and test specs, is that they all point out security by design and secure by default. So these are buzzwords that can be extracted from all the items in there. Yeah. As an end user, it's then a good thing to already apply stuff that's known today or highly will be coming highly with a highly percentage in these norms to already apply that today. So I mean, it's for sure it's about starting. When you start with your design, have one item security from the start on, and think about it. Use products or implement yourself products that allow end-to-end security. Yeah, most often, I mean, from internet communication, TLS or DTLS if you have non-connection based communication. So these are methods well established worldwide, but not yet well established over all IoT products. Yeah, so it's about putting those protocols and methodologies in the product you will want to create. A good thing is to assume zero trust by default. So it's about never trust, always verify, ideally in a mutual way. So mutual way means both ends, client and server, shall check who's the other partner and are they who they say they say. Yeah?
Exactly.
So that's about this. Then for sure, it's a good idea, and it from your smartphones. Software updates, regular software updates are a thing. If your system doesn't support it, well, maybe not so good idea.
Exactly. I think this is going to pose a huge challenge, not just for the users, but for the wireless module manufacturers in Europe, like, for example, our company. So any company who manufactures modules will have to react to this regulation and start offering solutions to the market.
Exactly. I mean, last but not least, mentioned here, it's also a good idea to include error reporting mechanisms, which would allow you to say, okay, somebody tampered with my end device. There was an intrusion. I have an error. If that message doesn't get forwarded to the cloud or to a central station, then you won't notify it.
Exactly. All right. Even though we mentioned many things here, we want to give you 2x5 general recommendations for security. One is applicable for end users and to your home, and the other group of 5 recommendations can be applied to any industrial office environment, manufacturer, or system administrators. Let's begin with the 5 tips on the left side. So first, credentials. We recommend you to change default usernames and passwords for all of your IoT devices. With many modules and many chips, you are going to find many hard-coded default passwords, default usernames, default SSIDs for wireless networks with default passwords. Don't use them because for most of them, there is already a script on the internet that people can just download and automatically attack your network. You won't even recognize, and people are going to get into your network. Network segmentation. We recommend to create separate network segment for IoT devices to isolate them from the main network and apply necessary security measures, like, for example, firewalls. It can be a software segmentation or hardware segmentation as well. Regular patching, exactly. Enable automatic updates, as you already mentioned. Principle of least privilege means disable unnecessary features and permissions on IoT devices. Don't use extra features that you don't need or you are not actively using. You just turn off them, and because they just simply serve as a critical purpose to to increase attack surface. So by deactivating them, you can reduce this attack surface. And conscious feature usage, as I mentioned, basically similar to the previous point. What I want you to take away from this, we want to reduce the area of attack, the surface of attack, to as small as possible. And for administrators and manufacturers, security policies, develop clear policies, train your users, educate your employees about the risks, and enable all of the security controls. Implement and activate all available security controls on IoT devices, meaning that all of the security mechanisms that are available, they are fully enabled to enhance protection. Device discovery, meaning you have to utilize tools to automatically discover and monitor IoT devices within the corporate network. Because if you don't know about an IoT device existing, then you might not know about it attacking your network. So obviously knowing about those devices is step number one. And obviously it's a logical last step, enforce all of those security measures. So if you already have some security measures, then you also have to enforce them and make sure that they are being applied.
I guess this is why everybody likes the IT guys.
Exactly.
Yeah, I mean, one item you will, or you may also face, or most probably will face, is a stumblestone of hidden costs. Yeah, so not taking that into account already in the design phase may come up with a system that will simply be too expensive for the end customer. Yeah, so we would like to give you some points on your way, which is try to prevent any on-site configuration. The buzzword here is zero-touch provisioning. So a system that just needs to be physically set up, plug the battery in, and it will connect to the internet. That would be preferable if you think on scaling. So yeah, you don't want to do that on tens of thousands of devices, like logging into the browser, selecting the right device, applying a certain set of rules. So that's one thing to consider with the topic hidden costs. Another thing to consider is certificate renewal. So some of the security policies will enforce you to update the certificates quite often, let's say 4 times a year or something like that. And depending on your subscription or provider, you may have to pay for each certificate renewal on each device, let's say 20 cents. Yeah, which is a huge amount of money if you multiply that by 10K exactly. By 4. Yeah, so that's a thing to have an eye on. Yeah, same thing for the cloud providers. Yeah, if they change their model, if they change their pricing, and you can not change to another provider, you are bound to it and need to accept that changes or discontinue your system. So you want to have a possibility to change the cloud at the end, the endpoint with all the set of security measures like certificates and accounts that are there. So yeah, and as you know it from the smartphone, we can point out often enough updates.
Exactly.
Yeah, but Next thing, let's have a short peek at applications. So I just see the time. We have a couple minutes left, Balázs.
Exactly, and we still have some things to mention. So, for example, 3 applications that Würth Elektronik already successfully provided to customers. Smart farming, which is a very famous demo of ours. We have already presented it in Berlin. And probably if you get in touch with one of our marketing colleagues, you are also going to be able to see it in person, because we are very proud of it and we show it at different places around Germany and around Europe as well. Digital tools. We are in connection with many customers who successfully made their power tools digital, reading out data, reading out operation hours, operation time, and many different parameters using our own sensors as well. And obviously Industry 4.0, which is another kind of a buzzword again. With our solution, customers were able to live monitor their production process live and to access invaluable information during the production without actually physically being present in the production line. How to design a security concept for an embedded device in a practice? Can you explain that?
Yeah, actually, that's quite a big package to explain. So what we want to provide here is give you a quick overview of what, for example, one of our system today already includes, which is hopefully a big subset of the things we are mandatory enforced to include like in 2 years. So we have things like secure production, which will provide a private key from our production line into the device, enabling secure boot, so making sure the firmware wasn't tampered with. Then we have a secure file storage, basically an encrypted partition on the flash memory that can contain data, which needs to be securely deposited in a non-volatile memory, for example. Yeah, for sure, everybody knows that from their browsers, HTTPS is a good way to go, which means secure end-to-end connection. Often, these security in your browsers will be not mutual, because only you as a client will check that the server is who the server says it is, but not the other way around. So that is a bit of a one end missing, so to say. Okay. It's sort of incomplete, but safe enough for you as a user. Then we have the root of trust, which basically says we have a certain set of authentities in the module that are and can be used for verifying all the secure connections. Yeah. So you have a base certificate that was inherited from a trustworthy instance, and that's all about these certificate chains. Sorry. At the end, updates again. Whoa. Exactly. So what I can point out, if you are interested in details on especially this product, we have a workshop coming up, which is our IoT workshop together with Mauser in our office in Munich. So as you'll be provided with the slides, feel free to register yourself. The best thing about that, I mean, it's November 8th, it's in Munich, and you'll get a design kit for IoT from our Wi-Fi design kit for free. And we'll take that kit actually in operation on that day and get data into the cloud yourself. So nice thing that the colleagues will offer, I guess. Sure. Exactly. Yeah. And then this is the kit. So if you want to take a peek beforehand, we have videos on YouTube.
Exactly. Feel free to put the presented title into YouTube search. You will find this video, or just use the provided link. Or if you want to see this device personally, just feel free to come to one of our marketing or sales colleagues, or just come to our workshop, and maybe we are going to show you some of these devices.
Exactly. And I guess this concludes our session today. So summary, I mean, no need to go through it again. We land at Q&A.
Sure. Let's see what kind of questions do we get.
Yeah, so I now stand up for a moment and I rearrange our monitor.
Okay, so first of all, thank you, Balázs and Jens, for the great presentation. And yeah, as you already said, now we are ready to go into the Q&A, so into all your questions. So if you have any questions now, just use the Q&A tool. You will find that on the lower right-hand side, there is a little question mark button. Also, if you have any questions after the webinar, just email us. You see at the moment the email addresses. So also, if you have a technical question, then just use WCS at we-online.com and you go directly to the technical support from wireless connectivity and sensors. So first question, which I can see here, how do you ensure that the modules remain secure over a long period of time?
Well, the first thing that comes into my mind is to establish secure channel where necessarily security updates, because security updates are probably going to be necessary, can be transferred to the device. That can be firmware over-the-air update in a standardized way that is going to be maintainable during a longer period of time, or any kind of a standard that allows security measures to be applied to the device.
Yeah, I mean, since this question with some variants came up multiple times again, let's point out that devices that are by themselves supporting TCP/IP communication, it's a really good idea to include measures for firmware over-the-air updates, which in principle mean you provide a signed image that gets verified on the client again. Then the root of trust comes into play again. The firmware verification comes into play again. So this will be a signed, let's say, binary image. However, it can be checked from the end device that it is allowed to apply that image. And for sure, we want to prevent something like rollbacks. So all firmware versions shall be neglected in terms of they already may have known security issues. So it's not a good idea to allow anybody to install a vulnerable firmware at the end. Yeah.
Okay, thank you to both of you. So next question is about, please can you tell me more about the smart farming use case? Just also there, the hint, I already answered this with, because we have there also a webinar about horticulture LEDs. So we also have there, knowledge material. You can get this in the video center on our homepage. Also just search for horticulture. But yeah, can you also add something to that? So tell maybe a little bit more about the smart farming use case.
Yeah. Balázs, can you paint us a picture of the demo we have and we've shown at Berlin?
Exactly. So we have a very nice rack of 3 levels of different plants that are utilizing our smart farming technology. It's a nice demonstrational device that not just is applying the smart farming LED horticulture kit from Würth Elektronik, but it also utilizes our own wireless connectivity modules, different modules of them, also our own proprietary, but also Bluetooth modules and Wi-Fi modules. With these modules, we can actually connect to the smart farming rack, and we can read the different parameters, just like the humidity, the soil moisture, and
pH values.
Exactly, that one as well.
Yeah.
Basically, we are using our own sensors for most of these values. If you don't know about it, you can feel free to check out all of our sensors on our Würth Elektronik website under the sensors menu. Yeah, I would say, and maybe as far as I remember, even on YouTube, there is a nice demonstrational video which was done in Berlin. So maybe if you search the Berlin Würth Elektronik smart farming kit, then you are going to be able to find that video as well.
Okay, perfect. Thanks.
Okay, thank you very much for your answer. Yeah, that's a good hint with that video. So then let's just move on to the next question. We have some time left for that. This one is a little bit a longer question. One security requirement of the EU or the European Union Cybersecurity Act for IoT devices is the requirement to enable software updates for the IoT device over the air. How can a secure transmission of a new operating system via the internet to the IoT devices be realized? How can it be realized?
Yeah. I guess we answered parts of it, but pointing it out, it's a bit of a difference. So you may have a subcomponent, for example, a Wi-Fi module that shall be updatable, but this embedded Linux points out that there is also the host, which we saw in one of the first slides, that shall be updatable, and therefore measures shall be implemented. Yeah. So to do that, in principle, it's always a good idea to have enough memory left that you can have a sort of recovery partition. So because you need to assume that it may fail or transmission may be aborted. So it's a good idea to have the option to reboot into the existing firmware. But at the end, if you when you checked everything, you shall apply the new firmware and boot from that and erase the old one. So the question is how to do that securely. Wi-Fi modules, for example, should allow you to do TLS communication, which will be a secured file channel. Yeah, and then, to be honest, there could be one option in between the host and a Wi-Fi module. This channel could be physically accessed. If you break open the device, you can contact the lines in the communication in between those devices. And this may be a valid risk for security if you can't ensure that some sort of tampering alarm gets out when the device is opened. Yeah. So these communication, often done over UART, USB, SPI, whatever interface, it's a good idea to also offer security on this communication, which would mean another set of keys to make a symmetric or asymmetric encryption there as well, which will be one of the methods coming up when the physical protection is not there. Yeah. So at the end, it's some sort of a risk assessment. Will my device be open? For example, if you fill it up with like plastics, it's really hard to open it, and mostly it's a question of, is it worth effort? So this is a trade of one of the security measures that can be done and are also aligned by the regulations that you shall do a risk assessment at the end and consider those points and check if it's applicable to your application or not.
Okay. So for my understanding, not so easy. If you have any questions left after, remember the email addresses you see at the moment. So one last question. What wireless or wired technology would you recommend now if I want to start a new design soon?
Yeah. Clear answer, that depends on your application. It's not that easy to choose the right one. There's a vast amount to be used, a vast amount of fresh communication standards pushing out into the open wild, so to say. For example, Meta. The big players seem to be on it, but if you look at the certification costs, which is a nightmare, you may reconsider the choice of Meta, for example. So at the end, please come to us with your application. We take our time. We go to the products with you and see that we can recommend a proper choice in terms of wireless technology or even wire technology.
Okay, so then big thank you for all the answers, Balázs and Jens, and also for your presentation again. Then I hope you all enjoyed the webinar, and yeah, I wish you a good rest of the day, and stay tuned with the last session or the last 2 sessions which are coming up on our Digital V Days. Thank you very much and have a good day.
Thank you very much.
Yeah, bye-bye.